Codex recently shipped one of its most powerful features and almost nobody is talking about it. Codex can now manage its own threads. A thread is just a single Codex conversation, one chat working on one task. And until now, if you wanted Codex to work on 5 separate things at once, you had to open 5 conversations and steer each one yourself. Now you can create one coordinator thread that is able to act like a manager, spinning up and managing other threads within your Codex application. So this might sound like a small thing, but it's honestly one of the most useful features I've seen in a really long time. In this video, I'm going to show you how I'm using this within my own projects to do more work faster than ever before. All of the resources are going to be linked for free in the description below, so let's get into it. So this is where I got the inspiration for this video from. You can see here that the Codex team recently tweeted out, if you ever get tired of managing your Codex threads, just let Codex manage them itself. So Codex can now create threads, search them, organize them, pin them, and spin up work trees for parallel tasks. Such a small change, but so powerful and so useful. All right, so let's get started with the demo. So the first thing to take a look at is the actual tools that we have available. So what we're going to do is ask Codex to list out these new thread management tools. Can you go ahead and list out all of the tools you have available for managing your own threads? So what you can see here is that Codex now has the ability to create a new thread. It has the ability to list threads, read threads. It has the ability to send messages to other threads. This is one of the most important concepts here, because a single coordinator thread can now talk to other conversations, and this is really powerful. It can also pin threads, archive threads as well. So this is useful if you want to clean up your workspace, for example, and it can also set the title of a thread. So Codex now has all of the features it needs to manage its own threads. So let's take a look at this in action. So what we're going to do is work on a project. So I'm going to create a new conversation again, and what I'm going to be working on is a coding agent that I'm building. And so what we're going to try and do in this demo is build multiple different tickets at the same time. So what I'm going to show you in this video is a coding agent I'm building called Neo. And the idea here is that it gives me the ability to experiment with different ideas when it comes to agentic coding, list files in this directory. So this is just a fairly standard coding agent. It's written in Golang, it's event-based, and it's able to do pretty much everything you'd expect a coding agent to do. But I have a bunch of tickets now on my backlog that I want to work on, so that's what we're going to be doing next. So what you can see here is the task board for this project. So you can see here I have a whole bunch of issues that I need to go and fix. So rather than working on each of these issues one at a time, I've got a bunch of relatively small things that I need to fix. So I'm going to use the new threads feature to spin up multiple different threads and work on multiple different tickets at the same time. So I've given this a prompt now. So act as the coordinator for this managed threads demo, coordinate 4 independent worker threads for these tasks. So we're giving it 4 GitHub issues that we want to work on. So these are 4 separate tasks that we're going to implement all at the same time. We're going to create 1 managed worker thread per task. Each worker must use its own branch and work tree. This is really important. So the great thing about this feature is that every single thread can run in its separate branch and a separate work tree. This is what allows you to do this kind of parallel work really easily. Each worker is going to be given a focus brief. So what we're going to do is follow a workflow for every task. So we're going to start by basically taking the ticket. We're going to implement the changes. We're going to write tests where appropriate. We're then going to use a sub-agent to review the work. And then we're going to address any valid feedback and then open a separate draft pull request. So we basically have one thread that is spinning up multiple other threads and managing all of the different work. This is going to be an interesting test of this new feature. So let's kick that off. So you can see here now that Codex is spinning up 4 separate threads. Hopefully it's going to name these correctly. Let's take a look at one of these threads. So you can see here we've given it a prompt. So each of these threads gets its own unique prompt. And when you look up here, you can see that this was sent from another thread. So you can see that Codex can communicate between these different threads. As it runs and as it coordinates all of the work, the main coordinator thread can actually inspect and chat with any of these sub-threads as well, which is really powerful. So you can see here now it's renamed the threads, which is good. So we've got preserve file permissions, add max turn signals. You could give it more guidance. As you go through this kind of work, you want to keep very organized. So what I probably should have done is given these a ticket number as the title of the thread, just to make it easier to see what's going on. The important thing to know about this feature compared to something like sub-agents is that each of these threads is durable. So it means that even after the coordinator has finished doing its work, you can still access these threads and you can still go into them. So this is very different to sub-agents, where the sub-agents only exist for the lifecycle of the parent agent. What's really cool about this particular example is you can see here that we have a coordinator that is managing multiple different threads. And then within inside each thread, you can see that the agent is spawning up sub-agents. So these are completely separate agent runtimes. The powerful thing about this pattern is that the coordinator is managing everything. So now it's completed all of the work, the sub-threads have finished. The coordinator can go in and check the work. It can orchestrate merging these in. It can orchestrate branch conflicts and anything that's going on. This is just such a powerful way to manage your work. What you can see here is that each of these subthreads is running in its own Git work tree. So you can see this has got a separate branch, and it's also running in a separate work tree as well. So this is how we can do lots of parallel work at the same time. So what you can see here now is that Codex was able to complete all of these tasks. So we basically fixed 4 issues running completely in parallel, and now the coordinator has summarized all the work. For each of these issues, we ran through a flow of writing the code, writing tests, and then also doing a code review as well using a subagent. So what I'm going to do now is go ahead and take a look at some of these pull requests. So these are the 4 changes that we just made. And you can see here that I ran some code review steps on each of these changes. They're relatively small, so we don't have much feedback. But you can see here we do have a comment here on this issue. So what I'm going to do is go back into the coordinator and then see if we can address the feedback on each of these issues all at the same time. Can you go ahead and review each of those pull requests? I moved them into ready for review. Now we have some code review feedback on each of those changes. Can you go and fetch all of the comments and implement any fixes that we need to fix, and then tell me what you did at the end of it? So it looks like the coordinator has looked through all of the comments, has found maybe one issue that needs actionable feedback. So this is in issue number 90. So it's going to go ahead and fix that by the look of it. Okay, so you can see here now we just reviewed all of those issues at the same time. So we have one valid comment that was fixed and then no other feedback issues. So it looks like everything is good. So what we're going to do now is use the parallel threads feature to clean up the old work. So the first thing we're going to do is ask the coordinator to merge all of those changes. Then we're going to ask it to close out all of the other threads. Can you go ahead and merge all of those changes? And then once you're done, can you go through all of the threads you created as part of this coordinator effort and then close them down so that we start from fresh? So as we jump back into the browser, you can see that all of those pull requests have now been finished. So if you go back and check out the code, those should all have been merged. So you can see just now we just updated a bunch of stuff. So all of those changes are now merged. We just need to clean up the old threads. This is one other example I want to show you of how you can get creative with this. So I created a coordinator thread, and the idea here is that I created a coordinator that would first generate a bunch of images. So we used the GPT model to generate a bunch of images. And then what I did is I had the coordinator spin up at 3 different website designs. So it went ahead and implemented 3 different website designs, and then the coordinator could then review each of those designs and decide which are the best elements to combine to create a better version of the site. So you can see here we generated 3 versions of a website. This is the first one. This is the second one up here. I actually quite like this one. I think this one looks good. And then we created a third one down here as well. So you can kind of see. So we created 3 different designs from those assets. Then the coordinator thread is able to merge the best bits from each of those designs into a different design. This is a really great use case for this kind of feature. This is the general pattern with this feature. So you start off by having a coordinator thread that you can pin. And then this coordinator thread can spin up different conversations, different threads. And then the coordinator can then converge and combine these things. It can basically let you run multiple different tasks at the same time. This is the kind of thing that I would use this for personally. So one of the questions you might have is, how is this different from subagents? So the difference is that a managed thread within Codex is durable. So it lives on after the work is done. You can leave the conversation open. You can go back into the thread or the conversation. You can resume it. You can iterate on it. So if you open up 5 or 6 different tasks, you can then jump into any of those tasks. You can iterate within those tasks. Whereas a subagent is just a tool call within inside an agent. So this is only temporary throughout the life cycle of the agent that spawned the subagent. So once the parent agent is done, the subagent will be gone. You can't go back into that conversation. You can't kind of resume or iterate within the subagent. It's just a tool call, a one-shot tool call, whereas a managed thread is durable. And so that's really the difference between these two. A workflow is different again. This is a repeatable process where you can run a sequence of steps. So we updated our coding agent. We did 4 tasks at the same time. The kind of things I would use this for are simple things where you have like multiple different tasks that can be done in parallel. You can probably push this idea pretty far. So for example, if you have maybe 5 or 6 different tasks you want to work on, what you can do is create one parent thread or a coordinator thread. You can pin that thread, and then you can ask that coordinator to work through all of the different tasks, spinning up separate threads for each issue. And that way, if you need to go in and inspect or like quality check or go through any items that come up in any of those issues, you can actually just jump into the conversation. So it gives you a lot of power here. Another idea that I would use this for as well is to run an automation that will auto-close any stale conversations. Obviously, managing all of these different threads, if you're working on lots of projects, is a bit annoying. And so what I would tend to do is create an automation that will run this thread management tool to clean up any threads that haven't been used in the past couple of days. Another good use case for parallel threads is to do some kind of review process. So I'm within currently a course. And so what I'm going to do is review each of the lessons, but inside a separate thread. Can you go ahead and create a new thread? You are a thread coordinator. For every lesson in the lessons directory, start a new Codex thread and then review the lesson, look for things that could be improved. So you can see now that Codex is spinning up all of the different threads. So hopefully Codex is going to go through and rename them and give them a reasonable name, because otherwise it's pretty hard to see what's going on. So now we have every single one of the lessons inside this course. Now we have a separate thread. Codex is running a review inside that thread. And that means we can kind of jump in. And so we can take a look at the feedback here. So for example, here we have a review here. We could go through and maybe accept any of these changes. We can start our conversation with inside this thread. But then also you can go through to the coordinator. You can maybe ask the coordinator to merge everything if you wanted to. So now you can see that we did all of these different lesson reviews. We could either jump into any one of these conversations, or we could ask Codex to maybe summarize the top 3 issues. The downsides of this feature are pretty obvious. The first one is that you're going to use up more tokens. If you're doing any kind of parallel agent work, then obviously you're going to burn more tokens because you're doing more work at the same time. While working on the demo, I actually hit my rate limits because I was spinning up, I think it was around 30 different threads. My computer was like on fire, burning. The fan was like spinning like crazy because there was just so much work happening at the same time. So you have to be a little bit careful here about how much work you're doing at the same time. You want to keep it manageable. The other thing that I struggled with when scaling up a lot, when I was working on 30 tasks at the same time, for example, I was getting a bit lost about what was going on. If you have 30 conversations and 30 different work items going on, the bottleneck is not the agents anymore, it's your understanding and your ability to manage all of that parallel work. So I thought this was an amazing feature. I use it myself often, and it's definitely one of the more impressive and underrated features I've seen in a long time. I hope you found the video useful. If you have any questions about this feature, let me know in the comments below. Thanks again for watching. I appreciate it, and I'll see you in the next video. Take care.